Welcome to another video of geometric dimensioning and tolerancing, in which we will learn about runout control. In our previous video, we have learned about location control. If you missed that video, I will encourage you to watch that video. I will provide the link of this video and the link of whole playlist of GD&T in the description. Let's begin with this video. So in runout, we have two controls: circular runout and total runout. Let's see circular runout first. This right here is the symbol of circular runout. So in circular runout, we use to measure the deviation in circular cross section. We rotate the part and we measure the deviation in the circular cross section. In case of circular runout, it only measures the individual cross section, or we can say it measures in two dimensions. MMC or LMC is not applicable here. So if you can see in this image, we have a part. This right here is at datum A. We will mount this surface in some spindle and we will rotate it, and we will measure the deviation in this surface with respect to datum A. So this right here is the feature control frame. In our first block, we have the symbol for circular runout. So this arrow symbol is the symbol of circular runout. In our next block, we have the tolerance value. The tolerance value here is 0.03. And in the third block, we have the datum A. So this right here is the datum A. Now let's see how we will measure the circular runout. So in this image, you can see this right here is the datum A, which is fixed on this surface. And after fixing it, we will rotate it. So this sign of rotation is here. And we will only have to measure the deviation in this cross section only, this red area. Here in this image, this right here is actually the same image, with only the difference we have attached a gauge here. So this gauge will only measure the deviation in this cross section only. It's written also here that it only measures the individual cross sections. So circular runout deals with the individual cross sections only. And here are some application of circular runouts. So circular runouts ensures that circular parts like drill bits, shafts, engine, transmission parts, spindles and chucks rotates smoothly around a central axis. And the main purpose is preventing these components wobbling during operation. Now moving on to our second runout control, that is total runout. This right here is the symbol for total runout. These two arrows indicate total runout. Total runout also measures the deviation in circular surfaces just like the circular runout does, but total runout do in 3D. Like it checks the variation in radial dimensions, and also it checks the variation in the axial dimension. We will show you it in the next slide. MMC or LMC are not applicable in runouts. All right. So if you can see this image, this right here is the feature control frame. It shows a symbol of total runout, a tolerance value of 0.030, and this right here is the datum A. So if you can see this image, we have almost the same setup as that of in circular runout, but here in this case we will move the gauge axially forward and reverse directions, so that we can measure it in 3 dimensions. So the total runout can be used where the surfaces are circular and larger as well. So here are few applications of total runout. So that's all for this video. If you find this video helpful, then please hit the like button and subscribe to my channel. See you in the next video.